So we start here with the 60mm board, and then to show that we can combine different thicknesses, we go on with the 80mm board here. So that's why we choose this 20mm cladding on the bottom. And then we have here, I call it mounting batten. Yeah, I think it's a good name. It's in the same thickness as the first board, so that we can, afterwards we can, first we can install the boards easily. We can first see that this is really straight, and that we know we will end with a whole board or with a easy to cut measurement at the top of the roof. So here we can define what width the board, the last board, should have. And also this makes it easy to install a metal sheet, for example, for leading the water into the gutter afterwards. So first for the mounting it's easier, and then to install a metal thing it's also easier. Another thing should be that you glue a metal thing onto the Ultraterm, for example. But this is a bit problematically for the water leading, but I will show you that afterwards. Yeah, then our craftsman will cut the boards. So the first board should be in the length or width of this measurement, that the next board can stop here. So we need a length of 36.5 from the small thinner board. This is the 60mm board. Yeah, could you please cut it? And you have to think, or you have to imagine, you have to know that the dust which comes can lead to sticking in the saw. So don't push with power, just cut slowly. You will get a feeling for that if you cut, so that the dust can get sucked off good enough. But now the saw just makes 55mm, yes. And then I guess I should put it on top. So then, before we install the second row of the boards, we think about the water leading and the rain leading, the leading of the water. Because now we have here a joint which is not sealed at the moment, and we would like to install a metal sheet here. And now, how do we do the connection of all those things? The easiest way is to use a membrane in the first row, and what I told you, that you have to put it just to the top of the tongue. So, what you shouldn't do is to lay it really around the tongue, because with this pitch it may work because the water is flowing very fast. But if you have lower pitches, then the water floats slower, and then it's possible that the water comes with the membrane into the construction. So then that's why we recommend to do it like that, just to the top of the tongue. It doesn't matter. So just to see how it works. Then we cut the thicker one, just to put it on top of here. So normally we fix this boards with the battens. So now it depends on what ventilation thickness you need. Normally in Germany we take 30 millimeters of thickness. It depends on the length of the rafters and the pitch of the roof. If the pitch is very low, then the how do you call it? The airstream is not strong enough. Warm air goes up, and if you have a lower pitch, then the airstream is too low maybe. So then it's possible that you have a higher ventilation area. Yeah, okay, then that. You can fix it with staples. So now we have a good water leading completely to the gutter. Afterwards, we installed the metal sheet at the, like that for example. Here's the metal thing, so the water comes here, then goes into the metal and into the gutter. This is the perfect way to do it. So I wanted to show what happens if you have a joint, if you have such joint in this direction. Because then you have to think about the water what passes there. For example, maybe we can push this a bit. Yeah, I think I can show it. So if we have a joint here, imagine we have a joint here, and you want to, you don't want to do it like that with the membrane inside. You want to glue the membrane on top of the boards. It's also possible, but you have to think about this joint. If you just glue it over it, and the metal thing, you lay the metal thing on top and glue a tape on top, then it's possible that the water comes through this joint under the tape. So then, if you want to do that, you have to tape this whole joint also. So if you want to tape here the metal thing, tape it here, and then tape also the joint in this direction, and then you're safe.
To the next row of
to the next row above.
plates. Yeah.
And also, if you have a damage on the board, for example, if maybe you stepped onto it, although it's prohibited, but maybe you stepped on it and you break it, and you want to tape it also, and you have such joint in this area, then you have to think about that and also have to tape this. And another thing is when you have windows in the roof, the window maybe comes here like that, the roof window. Then you have also a joint which leads to the window opening, and so just tape. So this is the main thing. Just think a little bit about the water, what the water wants to do. Yeah, and this is these are the most things, are the important things about the roof insulation. Sometimes, if you want to do high insulated buildings, then you need, for example, very big insulation materials or thicknesses, and then you have to use very long screws, for example. These screws have to be calculated by the screw producer. And another thing is, if you have on top of the rafter insulation, you want to see the wood construction, for example, and then you just put the insulation on top of it. Then it's possible sometimes, if you have very high insulated structures, that you need screws 300 millimeters or 400 millimeters, and then the roofer stays on top and has to drive the screws and has to be sure that he doesn't come out in the wooden cladding. so you have a nice view of the roof. And then there looks screws somewhere. So there are some guiding materials for that, for the screwdriver, for example. Or you do it like that you have the wood construction, a wood cladding on top, and then you put a rafter on top also, so that you don't have to use such long screws. You just have to fix the rafter construction on top and a thin sacking board on top. Yeah, this is one part, one possibility to install, to do this detail here. It does. So what you always have to think about is also the wind tightness of the construction. I said you have to keep the air standing inside of the construction, so you have to do a wind tightness. And the wind tightness is on the one hand the board, but if you have connections, for example, if you go against a chimney, for example, and you know this bad thing, if you have a wall coming from the bottom and you have to lay the insulation board on top, this is the last wall, and then you have to use something like a compriband or pre-compressed thing, what you lay on the wall, so that when you come with your wood fiber or with the insulation board, this area is not wind tight, and now you have to use a pre-compressed band which expands afterwards and secures the wind tightness. So all constructions have to be wind tight and rain tight from the outside. So these two words, and then think about a bit more, and then you have a really easy construction. Yeah, then we fixed the roof. It's raining outside, and we think it's raining, and we now can do the insulation from the inside. So with the Thermoflex, we now want to try the Thermoflex for it. So yeah, I think so. Flexible mat, but it is really, I would say, it's massive. If you take a board for we can do it like that. I will put it on the floor, and then we take this board just to show how massive this is, and to know that you should use the right thickness for the wood construction. So for example, if you have wood construction of, in this case, 140, you can't put into 150, for example, because you can't compress it like that. So if I walk on this with my 94 kilograms, I think, you can't compress it very much. Also, if you stand on the roof and try to press it, it is hard to do. Hard to press it for 3-4 millimeters. So this is the maximum. If you now you measure the width of the field or the construction. In this case, we have 59.5, for example. Yeah, 59.5. Then we add 5 millimeters to get a bit compression in this direction, and that it doesn't fall out of the construction. So then what is yes. Now we will cut it like that, yeah. Then maybe you can cut it 60, yes. And we often get calls from the customers who ask us. I don't want to use the words they use, but shall we cut this stuff? Because they normally try it with normal knives which you use for mineral wool, and this is nearly not possible to cut this. It's not as hard as hemp insulation material because the fibers are shorter than hemp insulation material. But we recommend this machine, especially this one. It's called Bosch GFZ, and normally with a wave knife or sharp thing. And the advantage of this one is that there are two knives, this one and this one, and they go
Wide.
Yeah, and this is also the reason it works well, because you don't lose energy while cutting. For example, if you use a Stichsäge, a normal pendula, yeah, then it can happen that the whole mat is shaking, and then you lose energy to cut. So we recommend those ones who work like that. And we also have a knife in our product portfolio to cut thermoflex, but this is, I think, for small or for little building sites or for private use, not for if you want to do it as a carpenter or stuff, because this takes lots of time to cut. Yeah, and then we try it with this one. So normally you can also make it like that, and then you can cut it from the back. It doesn't look so nice, but it's possible that we should first have to sharpen it again. Just. And then we have a installing direction. So we recommend to put a cladding or a membrane on the inside lately after 3 days, because then it's possible that the compression to the sides is going down and it can fall off. So we say that minimum after 3 days, or maximum after 3 days, it should be safe. So this is here we have two sides. This one is a bit rough, a bit bigger fibers. This one is finer fibers. We say this side to the carpenter, and we tried to suck off as much dust as possible in the production, so that you don't have to stay there and make like that. Because this is what the customers first said. Wood fiber would produce much dust, and this is a bit better. Yeah, and now I think it's clear that we put this in, and then we would insulate. We would do the air tightness and the OSB. We use an OSB as air tightness and also as the vapor barrier on the inside. So we normally recommend to use OSB on the inside, or because you can use it as a vapor barrier, as an air tightness, as a construction layer to fix gypsum boards or clay boards or what else. So, and you can use it as for the statical loads, for stiffness and so on. Yeah. Then normally we have to tape this one that is really airtight. So otherwise our blower door test will not work. I just decided that we don't fill everything with flex. Normally we would do that, but I think the progress is clear, isn't it?
Yeah.
So how to cut flex? It's no miracle or what. So then we have here a model of a outside wall, and we would like to plaster it. So we take the Thermo wall. Thermo wall is this one here. For those who are new with the Gutex material, just have to know that Thermo wall is the family for plasterboards. There are many other boards. They are all called Thermo wall. Some called GF or N or NF and so on. But just to know, Thermo wall is a plasterboard. That's enough. And the GF in this case is especially for wood frame houses. The Thermo wall is a thing what is regulated by approval. So in Germany we have an approval for the ETICS, external thermal insulation composite systems, and there is fixed. The boards are fixed, the plasters are fixed, and also the substrates where we can put it on are fixed. And this is I say something I will say tomorrow again a bit, but this is what you really have to keep in mind. So to say it double time, it's not so bad. And also the base construction is fixed. So that how to deal or how to do the first row, for example. And so in this approach, they say that you need such thing. This is the profile, a metal profile, where you put in the thermo wall board, and this one bears a few of the loads which come from above, but it also protects the board from the bottom, from water and raising damp and something like that. So you first have to mount this one, and now it's also important how high the board, when the board starts. Normally we have the splashing water. In Germany it's from the level 0 up to 30 centimeters. This is the splashing water area where you should prohibit to use wood things. So there are some ways to deal with that and to go to 5 centimeters from the ground to the first wood thing. But those are details which I will show tomorrow a bit, and we have on the website many of those. They are based on the DIN, the wood protection DIN, and also Austria has lots of a lot to do with wood frame house and so on. And I can show a bit tomorrow about that. So now we say our construction is 30 centimeters from the ground. Although it's now 5 centimeters, it doesn't matter. We say it's 30 centimeters, so out of the splashing water. And then we have to cut this one in the right length. So we imagine that we have an XPS underneath this metal thing. So the only thing Gutex is not able to do with is insulation material for inside of the ground. So it's all under the ground surface, because it's still wood-based material, and so XPS has its right to be there, because for that you can use it very good. Now we will cut the groove away, and then we can put the board into the metal thing. The groove start. Yeah, no. The groove is a problem because then we have an air gap in between the composite system, and there it's possible that that damp rises or moisture rises. And also, if you look on such aluminium stuff in the climate nowadays, or in the actual climate, then it will we will have condensate on the surface. So if we have cold nights and warm days and so on, then we have condensate on this, and so we want to use the ability of the wood fiber to suck off the water completely. So we try to put it as tight as possible to the material. So we have to cut out the window, and this is the same thing as in the when you install gypsum boards or something like that. You have to you shouldn't have joints in the leading. How do I say that? So if this is the opening, you don't have to have a joint in this direction, and also not in this direction. So you should cut out the board like that, like that, like that, and like that, so that you have a completely board around the edges. Because if you open a window and close a window, then you have dynamic loads. This is if you smash the window, for example, then it's shaking the whole construction, and then you have the possibility raises that there you get cracks. And in an external insulation system, it's really bad if you have cracks there, because the plaster is the thing what secures the rain tightness of the construction afterwards. So just do it like that. Cut it out, or if you have it like that, if you have a joint here, just cut this out. But never do that. That you have a joint like this, like this. So always go into the hole and cut a piece out. This is necessary. The fixing, you can fix it with screws, with a mushroom head dowel, like that. You see there, 6 centimeters diameter of this thing, and you have to. And you have to fix it until the surface is even. You always have to. How it works with this thing. Yeah. Wait, it doesn't work with those. No. It's yeah. Okay. So normally you have to secure that you have an even and same thick plaster layer afterwards. So if you drill the screw too tight into the construction, you have afterwards a thicker base layer or a plaster layer there, and the thicker plaster layer leads to more material what can absorb water. And if you now have this climate like that, cold nights or days, then you will have condensate in these areas, and the thicker plaster layer will keep the water longer than the rest of the board. And so you get this typical sign of external insulated walls that you see the dots everywhere, the screws. This is one thing. And the other thing is, if you can't screw it as tight as necessary and you have a thinner base layer, plaster layer, then you also have you will see the dots, but then not because of too much water storage capacity, I will say, in this area, because the material can't store as much water as the rest. So the rest will stay longer wet and cold, and the dots will get first warm and dry. So try to do it even to the surface. Here, yeah, the things are not correct ones. If you install polystyrol, for example, then you normally have to drill a hole for the screws and for the plastic things. They call it. How do they call it?
Este ciuperci cu care se prinde polistirolul. Yeah, fixă pe polistirol.
Yeah, you have to do it deeper.
Exactly.
You have little pieces which have the right size of the drilling thing. Then you drill a hole, you fix the screw, and then you put it in that little piece that the screw is isolated from the outside also. But this is not necessary in the wood fiber. In the wood fiber, you just have to use the right plastic ones and screw it even to the surface.
There are homologated ones from Gutex, or you can use anyone.
Yeah, in Germany you have to use the ones who are written in the approval. And I don't know how it is, but yeah, European countries, I think you are safe when you use those we have. So now, if you have a look here, you see that this metal piece stays a bit for the facade. You see there's a little step, and now we can install this one here. Now we should cut this. Yeah. Now you see, if we have the board here, I think this is the same thickness. Yeah. You see that here's a little gap or a little step, and this is for installing this this mesh. It's easier to show. Just put it on top, like that, and then you have a really good connection between the plaster and the rest of the construction. And now it's rain tight, and yeah, what you should think about is that you doesn't press it hard like that. Just go a bit upwards because of the thermal moving of the metal things. So just put it a bit up, and then it can move inside of the profile here.
Coming with the old system. Yeah.
Yeah, this. You don't have to use the Gutex stuff concerning this one, but I think every plaster producer also gives you such profiles.
Yeah, there.
So this is a good thing to do it like that. And then you can put the plaster onto. you have to overlap the mesh 10 centimeters. So this is 10 centimeters, and this is also 10 centimeters.
Okay.
And so, you know, you take the mesh from the surface completely, and let it go down, and then put this up, for example. And so there are many different profiles from many producers, which have for every special connection you normally get the profile. Also, if we have facades over 15 meters long, their length, we recommend to make a gap between, that the construction can go wider and go smaller. Therefore, there's also a profile which you can plaster in, and this covers the gap and secures also the rain tightness of the thing. Yeah, that looks good.
But he's struggling with it. So is it a solution to first put this net and then stick the board in?
Doesn't matter.
No, because I saw it was difficult for him, and he's a pro, so.
Here it's a bit difficult because of the wood construction. There we went too deep with this thing,
okay.
So the plastic one was in the way. Yeah, and also in this here, the same thing. No, normally you mount first the wood fiber boards and then do the rest. Yeah. I think, what can we show? It says the time. What is recommended in many details is the compri band, the pre-compressed band. Also, if you have things like that here, if you come up with a board like that, and in this case, I think you can't see it really. You have to go between the rafters under the cladding compressed band, because there it may occur that the wind blows behind. So wind tightness and rain tightness are the two base words for the constructions mainly. That I've said. If you afterwards put on the plaster, we recommend to do it, the base layer in two parts. So the first part should be that you use the base layer plaster with a tooth towel. You know what I mean, the tooth towel, and put it on. And the tooth towel has a thickness of, for example, 6 millimeters or something like that. And with this, you can make sure that you have the same thickness of plaster everywhere. Just do it. Then let it dry, and then you fill the toothing with the base layer plaster again, but then not with the tooth towel, with a even one. Fill it, and then also put the mesh into the construction in the plaster, and then you know that the mesh is in the right depth of the construction. You say 1/3, ein Drittel. You know, the mesh has to be in the last third of the plaster, so that it can bear with the loads which come. So then plaster, put the plaster on top and let it dry, and then you do the outer plaster, so the last plaster layer. Yeah, and this is, for example, for the ones who wants to do it on their own and don't have much experience with plaster. There are many plasterers who say, I can make sure that the mesh is in the right thickness or the right depth. I will do it like I've ever done it, with no tooth towel, just with one thing. And it's also okay if you can just make sure that it's in the right layer, and it's okay.